I am going to describe about nitrite ion today. First, let us draw the basic skeleton. Nitrite ion has two oxygen atoms and one nitrogen atom. So nitrogen is going to be the center atom and it has one negative charge. So we have to count how many number of electrons are available for the bonding from each atom's valence shell. Oxygen atom has 6 and nitrogen atom has 5. So altogether, 2 oxygen atoms and 1 nitrogen atom give 17 electrons. With the negative charge, it will add up to 80. So we will complete the octet of these oxygen atoms. So we used 16 here. So 18 minus 16 mean 2 electrons. That 2 electrons would go to the central nitrogen atom. So they are available as lone pairs. So when we check the center nitrogen atom for octet rule, it has 6 electrons so far. So it requires another 2 electrons. So we can fulfill that requirement from taking 2 electrons from either oxygen atom. So it will result double bond and this will remain as with single bond. So then we can see 4 electrons are available for nitrogen here. 4, 6 plus 2, 8. So nitrogen has completed the octet now. So then we have to determine the charges. So I am going to put the numbers 1, 2, 3. Then I am writing 1 into 4, 3. So oxygen has 6 valence shell electrons. Nitrogen has 5 valence shell electrons. Again, oxygen has 6 valence shell electrons. So when we count the number of electrons available for their valence shell, we have to consider these two lone pairs mean 4 electrons and only half of this bonding electron. So it means 6 electrons. When we come to this nitrogen, 2 plus 2, 4 plus 1, 5. So finally, this oxygen has 3 lone pairs with 1 electron. That means here. So 0, 0, minus 1. That means the negative charge should go to the oxygen number 3. So I can remove the numbers now. Then it is clear. So this oxygen with single bond has negative charge. Now we will consider the oxidation numbers. When we come to oxygen number 1, it is bonded to nitrogen atom. Obviously, oxygen is more electronegative than nitrogen, so it has the ability to withdraw the electron cloud of the two double. So, in addition to the 2 electrons given by this oxygen atom, it can withdraw 2 electrons from the nitrogen also. So, it can feel extra negative charges come to itself. Extra negative charges mean electrons. So that means it has -2 oxidation now. So when we go to the nitrogen named as N2, because of this withdrawing electron, nitrogen gets positive charge. And also here, there's a single bond. From this one, it gets 1 positive charge. From this double bond, 2 positive charge. And this one, 1 positive charge means +3. So when we come to here, on the single bond, it gets one negative charge. Already it has negative charge altogether. It should get -2. Now we describe about the geometry of the molecule. So this nitrogen atom has lone pair electron. So we can write there is a repulsion between bonding pair electrons and lone pair electron. So it is a strong repulsion. So this molecule cannot be hold on linear position. As a result, it has to go to the bent shape. So this is bent shape. Now we move into the hybridization. So when we come to the oxygen, number one, it has full lone pairs and one sigma bond. So it requires 3 hybridized orbitals. So O1 can get that hybridized using sp2. When we come to nitrogen atom, it has one lone pair and 2 sigma bonds. Again, it needs 3 hybridized orbitals. So it can get that using sp2 hybridization. When we come to oxygen number 3, it has 3 lone pairs and 1 sigma bond, mean it needs 4 hybridized orbitals. So it has to go to sp3 hybridization.